Hello, hello, and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and we talk about all things Gen Chem related on this channel. During this video, I'm going to show you a quick way that we can use density as a conversion factor in doing some of this dimensional analysis. So we've learned how to use the density formula to solve some of these problems, but I just want to show you an alternative method for using density as a conversion factor and really leveraging the units that are present. Let's get started. Okay, so I just want you guys to remember what density is. We learned before on a previous video that density is equal to the mass divided by the volume. And because of this, nothing is canceling out. The units end up being in a gram per milliliter unit. Well, that gram per milliliter unit, we can use that as a conversion factor. So when I say something like water, which has a density of 1.0 grams per milliliter, if I wanted to write that out as a statement, that's the same thing as saying there's 1 grams of water for every 1 milliliter of H2O, or they're equal. Or the density of lead is 11.3 grams per centimeter cubed, which would mean that 11.3 grams of lead is equal to 1 centimeter cubed. So we can use this conversion factor, this density, so we can use this density as a conversion factor. Where now, if we're saying, okay, well, how much does 4.0 centimeters cubed of lead weigh? So that means we're ultimately trying to solve for the mass of lead. And our starting point is our 4.0 centimeters cubed. Well, because we have this density unit here, this density conversion factor, we can use it as a conversion factor. So we would simply be placing those units here on the bottom, so centimeters cubed to grams, and we would be ready to plug in. So in the gram amount up top, we are going to say that it's 11.3 grams. On the bottom, we would put 1 centimeter cubed. And we would be ready to plug it in. So we would say 4.0 times 11.3, and that gets us 45.2 grams of lead. With proper sig fig, since there's only 2, we would just say 45 grams of lead. And this is just another alternative way of thinking. We would have come to the same conclusion if we used just that basic density formula or even that triangle that I showed you guys previously. So density equals mass times volume. So in the case here, we're looking for the mass equals density times volume. Well, that's exactly what we've done in this example. Okay, we'll try one more example here. So it's asking us how much does 3.0 times 10 to the second milliliters of ether weigh? And they've given us the density as 0.71 grams. So again, we will start by saying that my given is 3.0 times 10 to the second milliliters. I'm trying to solve for the grams. And so I can do this in a single step using density. On the bottom, I would put milliliters. On the top, I would put grams. And then we would fill it in accordingly. There would be 0.71 grams for 1 milliliter. Plug that into your calculator, 3e to the second times 0.71 divided by 1. We end up with 213 grams. With only 2 sig figs, the proper way to show this with 2 sig figs would be to either do it as, we can really only report up to there properly. And so we can't just write 21 because that would not have the same weight. We would have to either A, add a 0 like so 210 grams of lead, or we would write it in scientific notation as 2.1 times 10 to the second grams of lead. Either form would be acceptable to show the proper number of sig figs. I hope this video helps. Stay tuned for more videos related to Gen Chem. See you guys soon. Bye.